Hello all, this is me. I have overall 14 and a half, 15 years experience. 8 years has been into extensive training and I've until now accomplished 40 plus big data analytics engagements. And recently we renamed the company from XLR to 360 Digit MG in Hyderabad, in Malaysia, and in 33 different locations in India. Those are our franchisee learning centers. Digit MG stands for Digital Transformation, Management, and Governance. We believe that there is digital transformation going on in the world that we live in. There is industrial revolution in a big way. Hence, we thought we have to rename ourselves to suit the current industry requirements. These are the bunch of certifications which I possess. Just in case you want to cross verify, you can always do that with the ID numbers. Project management, agile, DSDM, Atern, Lean Six Sigma, Green, Black, Master Black Belt, Tableau, risk management, ITIL, so on and so forth. I've started working with HSBC. ITC Infotech was the second company, Infosys the third, Deloitte was the last company with which I was employed as an employee. I happen to be director of both 360 Digit MG and InnoDataTix. InnoDataTix is mostly into analytics consulting, and 360 Digit MG is mostly into trainings. I also happen to be a chief data scientist on these four firms and a visiting faculty of Watson Business School. That's in short about maybe a boring profile. Without wasting much time, let us get into this particular webinar, and welcome to 360 Digit MG. This is a free webinar. We keep conducting free webinars and we keep bringing in amazing and interesting concepts for our participants, for the wider community to get benefited, right? So today we are going to discuss about project management methodologies for handling AI projects. AI is kept there because nowadays it's all about artificial intelligence, right? The regular machine learning algorithms are kind of being sidetracked to a very great extent. And hey, sorry about that. That was my kid disturbing me. All right. So it's not just artificial intelligence, but data science and all the other machine learning projects also can be accomplished using the project management methodologies, which we are going to discuss. And the shallow machine learning models that we have might take a backseat given that explainable AI is being researched upon in a big way. Anyways, that's out of scope of the webinar, so let's get started. We will quickly discuss about how did AI evolve. Then we are going to discuss about the various frameworks that we have for building the AI systems. Then we are going to discuss about KDD. You will learn about what this KDD exactly means. And then you will also learn about CRISP DM. And this is very famous, guys, and one of my favorite things also. We'll discuss about that also. And you'll discuss about SEMMA. And finally, we'll wind up. But even before that, I would like to just take quick half a minute break here while I pull up the other document. Yep. So sorry about that. Let's proceed further. So let's discuss about AI evolution first, and then we will move on with the project management methodologies which we are supposed to discuss. Do you know what? This is a thing of past. It's not present. Neither is it future. Artificial narrow intelligence. This is nothing but if you build machine learning algorithms, machine learning means predictive modeling, basically, right? Which is similar to human intelligence. If you can build something which is similar to human intelligence at one specific task, right? For example, security guards are very good at sitting at the entrance and trying to identify if there is a visitor who is trying to enter the premise or not. This very thing can be replaced by a robot, right? By having a robot in which you will build an algorithm which will identify the human face. Pretty simple. For that case, you have examples such as IBM Watson, right? Within IBM Watson, you have this opportunity of supplying data, even for that case, R, Python, etc. And then it's going to do a specific task for you. But this is a thing of past. If you're still stuck here, God save you, right? And what is the present scenario? Present scenario is artificial general intelligence. Here, if you can build a machine learning algorithm, which is very similar to human intelligence, but if it can do multiple tasks in a specific area, right? Rather than solving a specific task or a problem, if you can address a specific area as such, then it is artificial general intelligence. Can I quote a few examples for you? Oh, why not? Self-driving car. Self-driving car, for example, is something which is related to artificial general intelligence, and the work is currently going on as we speak, right? What are the various tasks or problems that are solved when it comes to self-driving car? When it comes to self-driving car, one thing is you need to handle your steering, right? Should you go left or should you go right? Should you take a U-turn, etc. You also have to apply brake. If there is a red signal ahead, you have to apply brake, right? And then you have to switch your gears, right? You have to also switch your gears. So you're doing multiple tasks at one go in a specific area, right? That is the world that we are living in now. And if you have your wife alongside, seated beside you, you also have to talk with her, right? So that's additional task. So managing the steering, applying the brake, changing the gears alongside talking with your wife. Multiple tasks at one go. If you can build that intelligence, it's present, right? Artificial general intelligence. Then you have one thing which is about future. Artificial super intelligence. If you can build machines using machine learning algorithms or predictive modeling, etc., and if they can be smarter than humans, if they can handle tasks better than humans, that is ASI, artificial super intelligence. I mean, I keep seeing these videos. I mean, of course, those are all, I would say, fake videos, wherein there will be a robot and then people will be kicking it, beating it, firing at it, and they expect that particular robot to be smarter, stronger, and intelligent than a soldier. I've seen that. That is future. It's not built yet. That was just a fake video using some Adobe Photoshop kind of a thing. But yeah, that is going to be the future, guys. And another thing is explainable AI, XAI, right? At this point of time, the one thing which is a major drawback for deep learning algorithms is explainable AI. You cannot interpret the model. The moment you have the interpretation built in, all the other machine learning algorithms will take a backseat and slowly fade away. It will be a thing of past. Okay, here are the three frameworks for building AI systems. We will, of course, not delve deep into this. However, at a superficial level, yes, we are going to discuss these. The first thing is KDD process model, which is knowledge discovery databases, oldest of the models, which will help you build your data science applications or machine learning applications or data mining applications, etc. Right? And then you have CRISP DM, which is cross-industrial standard process for data mining. Okay, this is yet another framework which people use heavily, especially I use heavily. And the next webinar is for 4 hours doing a deep dive into CRISP DM. It'll be split into 2 sessions. And then you have SEMMA, which is sample, explore, modify, model, and assess. So these are the 3, majorly or widely available project management methodologies using which people accomplish data mining applications or data science, or for that case, AI, etc. To demystify a small thing, what I wish to do is, okay, let me put it here. Your AI is this big onion peel. The next is data science. Within data science, you have something called as data mining. Within data mining, you have something called as machine learning. And within machine learning, you have something called as deep learning. And in the world that we live in, majority of the AI applications are built using deep learning algorithms. That's nothing but neural network. Neural networks is being used heavily. Okay, this high level picture, just bear in mind. Okay, now let's discuss this. DIKW. Okay, you have data, and when you have data, you will process that data, right? Data is in its crude format, and it would be in its most raw format, right? When you take the data and when you process it, when you try to do some kind of visualization, etc., you would get some information. Using that, you know what is going on in the data, right? You know what is going on in the data. Once you know on what is going on, is my sales increasing or decreasing, or is it staying constant? Are the number of loan defaulters increasing? Are the number of credit card transactions, more number of credit card transactions being termed or classified as fraudulent? What's happening basically, right? Once you know what, and when you use this knowledge of what to understand on how can I solve this, that is when you move from information to knowledge, right? Data is in its most crude format, like Excel sheets, etc. From that, probably if you do a pivot table or some visualization, you'll get some information out of that. Using that, you're trying to apply your domain knowledge or apply your learnings. That's the third stage, knowledge, right? Wherein you want to know how to solve the problem that you have identified, right? And the final stage is wisdom, wherein you know exactly on why you're doing that. Why are you taking that action? Hey, more number of loan defaulters are there. Good, you know what? How do you solve that is a solution that you come up with. But if you know why you're exactly trying to do that, if you're confident that it's going to solve your problem, etc., then you will reach the highest level of decision making. And at that stage, there will be absolutely no risk. But the data in its most crude format has humongous risk, a lot of risk in it. Okay, so, uh, all right. Next, let's discuss about KDD. That's more from understanding about what is this data. People keep speaking about information, right? And data and information people use interchangeably. Wrong. Right? From now on, at least, I believe you'll be able to use it properly. Then KDD. KDD is all about discovering knowledge from data, knowledge discovery databases, right? From data, we want knowledge out. We don't want to stop at what's happening, but we want to know this part. How do I solve it, right? That's the stage that we want to get into. And this concept of KDD was first introduced to the world in the year 1996. It's not new, friends. It's more than 2 decades old. It has a history of roughly 23, 24 years, right? And this particular KDD says that we need to integrate a lot of technologies together. Data warehouse or data lake, coupled with statistical machine learning, couple that with your data optimization, couple that with data visualization to present it to your customers, and then perform parallel computing, etc., etc. All that is part of this framework, right? Basically, let's read this. KDD, it is centered around the overall process of knowledge discovery from data. That covers the entire life cycle of data. That includes how the data are stored, how are you going to access that, what algorithms are you going to use, how your algorithms can be scaled if the data increases in size, right? And how the results can be interpreted and visualized and presented to your end customer. There are basically 5 stages. Okay, it will sound very, very familiar. One. Second, all the 3 project management methodologies which we are going to discuss will have a lot of overlapping stages. Okay, the first stage is selection. Here, you need to select your data. We cannot just like that blindly say that, okay, customer, I believe you have data for the last 3 years. Can you throw that data at me and let me figure out what data is important? Guys, according to European Union GDPR norms, you cannot have access to more data than what is required for you to solve the problem. Number one. Number two, even if you have data available with you, you cannot use it for some other purpose. If you say that you're trying to solve a specific business problem, you can use it only for that purpose, right? So anyways, that's all about data privacy and all that. But you cannot have access to more data than what is required for you to solve the business problem. Hence, you have to do your market research and identify exactly what data you need from the customer. It's all about selection and integration, right? So you're going to select what data you need. You need to integrate the data as well, because you'll be having data from Excel sheets, data coming in JSON format, data coming in from IoT sensors. You'll have a lot of data, batch data, streaming data, all that data coming your way. So you have to integrate all those disparate, heterogeneous data. It's not homogeneous, it's not of similar kind, it will be of different kinds, right? And then you integrate and keep it available. Once you have that, You're going to select subset of variables which are relevant for your analysis, right? And then only extract or retrieve those data, those variables. So it's all about bringing in data from various sources like probably Excel format or JSON format or etc., etc. And then you're going to put it in a database or a data warehouse or a data lake, whatever you want to call that. From here, you're going to choose subset of the data or important variables which are required for your analysis. That is the first stage of KDD. What happens next? Let's see. Processing, pre-processing, very important, right? Because the data that you receive, you cannot expect it, number one, to be clean data. Number two, in the format that you want to proceed further with your data science or AI project. You will have incomplete data. You will have outliers. You will have missing data. You'll have data inconsistencies, you'll have duplicate data. Same customer might be appearing twice in your database. For example, one row could be Bharani Kumar, another could be Bharani, the third one could be Bharani Kumar Depuru. All these three are of the same customers, right? Who would have probably registered for credit card using only the first name and last name, applied for loan using last name, first name, and surname, or maybe forgotten surname. So various things. So you have to pre-process basically. So even before you pre-process, you need to have your strategies in place, right? For handling various things. Outliers, how do I deal with it? Right? Handling missing data, how do I do that? Do I delete the missing values completely? Or do I impute with some techniques such as hot deck imputation, etc. Right? So all those things are part of pre-processing. Once the pre-processing step is done, you move to transformation. Okay, here when I say transformation, there are many things. For example, there is a concept called as smoothing. Within smoothing, you can do binning. Guys, if you are not aware of binning, grouping, all of those things, do not worry. The next webinar will be for 4 hours. All these things would get covered, if at all you're interested. So performing clustering and then thinking about applying your models on each cluster, right? Or there is something called as dimension reduction using, say, PCA, principal component analysis. Maybe you have taken a lot of variables, you might want to compress those into one or two variables, right? So all those things basically. That's smoothing basically. Aggregation. If you have data which is daily data, you might want to aggregate that to weekly data or monthly data or quarterly data or yearly data. Depends on what is the frequency to which you want to aggregate the data. Or if you're given monthly data, can you disaggregate that to fortnightly or weekly or daily data? For that case, if it's stock market kind of data, even hourly data or minute wise data or second wise or microsecond wise data might make more sense. Who knows? Then in this transformation, you also have normalization, right? Normalization, standardization, interchangeably used. You have min-max concepts of scaling, Z normalization, standardization, etc. You can apply PCA or you can apply MDS. There are many other techniques which are available, right? These are all part of transformation. Once you are done with transformation, then you enter into your data mining. Within data mining, sometimes the goal of the project could be only perform descriptive analytics or only perform inferential analytics like hypothesis testing, etc. Or the goal could be predictive analytics, predictive modeling, etc., regression and all that. Or the goal could be, hey, can you just help me create different clusters? That could also be another goal, right? So you might want to do that also. Here, the goal is in transformation, when I speak about clustering, I'm just saying that maybe the data is heterogeneous. You want to make it homogeneous. Hetero means variety of data, right? You want to make it homogeneous, maybe. That's the goal that I'm speaking about. In data mining, you're actually solving a business problem using clustering. For example, your bank might say, hey, there are 1 million customers. Can you group them such that I can target each segment separately? For example, all the affluent society would form one cluster. All the sports personalities might be another cluster. All the student community might be the third cluster. Who knows, right? So from that perspective. And finally, it is about evaluation and interpretation. Two things. It's not just evaluation, it's all about interpretation. At this point of time, deep learning lacks interpretation. So if you're applying KDD, most often than not, you will take a back seat when you move to this stage of evaluation or interpretation. Evaluation is evaluating whether your model is accurate or not. Did it solve your business problem or not, etc. And then interpretation means you should be you should be in a position to explain on what is this equation telling you. If some regulatory body comes to you and says, hey, can you explain me about this? You should be able to explain. For example, say you're trying to predict income, or rather salary of people who undergo, say, data science training. So that's the output. You'll get some values such as 1.2 plus 1.3 into age plus 1.5 or 0.5 into educational qualification, so on and so forth, right? So these values, what they mean is, if you increase age by 1 unit, that is maybe 1 year, then the salary will increase by a factor of 1.3. If you increase age by a factor of 1 unit, that's 1 year or 1 month, whatever be it, your salary will increase by a factor of 0.3. So this interpretation exists. However, if you use neural networks, you'll get a similar kind of equation such as V plus W1 xi plus W2 x2 in that way. Weights, these are weights. If you get certain weights such as 0.2 minus 0.8 into age plus 0.7 into education, something on those lines. If someone asks you, hey, what do you mean by 0.7 or what do you mean by 0.8? All you can say is, I don't know. This is black box. I cannot interpret those. So you will get stuck with respect to that. In life sciences, healthcare, as well as financial services, insurance, and any mission critical applications or domains or industries or sectors, they ask you for interpretation, right? And that's what I was saying, right? DARPA, US DARPA, you can just do a research. They have embarked on explainable AI. And once they have their heads on, anything is possible. Okay. Let's discuss about the next project management methodology here, which is CRISP-DM. Cross-industry standard process for data mining. It was established basically by European Strategic Program on Research and Information Technology Initiative. As part of that, people wanted to come up with an unbiased methodology that is not dependent on any domain, that is domain agnostic. So this model can be applied to no matter what industry or what sector or what domain you're working in. Irrespective of that, you can apply this. Okay. Once again, you know what? This idea came to light in the year 1996. So look at this, 25 years of backing each of these methodologies have, right? But it took them 3 years to publish, and they published this crisp DM in the year 1999. Okay, and then they started, improving upon that. And this particular crisp DM was named as the #1 data mining and predictive analytics project management methodology in 2002, 2004, and again in 2007. And people thought we have to take this to the next level, right? But yeah, in bits and pieces, it's happening in an unofficial manner. But yeah, this is crisp DM for you guys. I mean, I'm a big fan of this, and the next webinar for 4 hours is completely focused on this. Here are the 6 steps, friends. First thing, understand the business, right? You need to first understand on what is the problem that you're trying to solve. And the moment you understand the objective on what you're trying to solve, you also have to, from the business perspective, convert your objectives into data mining problem definition. So from business, move to data mining problem definition or data mining understanding, if I were to put it in that way. Right? And then you will also have to understand here on what will be the performance measurement criterion, or how are you going to evaluate your outcome, right? This is something that has to be agreed upon upfront in business understanding. There are a bunch of documents which you have to follow. Next webinar, folks, not now. Okay, next, once this business understanding is clear, you move on to the next step of identifying the requirements, right? You have to do gap analysis. What data is relevant to you? What data is not relevant? What are the data quality issues that you're going to run into? Right? All those things are very important. And this is an iteration process. Whatever is the outcome of your data understanding, you supply that as an input to your business. And this happens iteratively. Based on this, in most cases, the business problems are redefined. Because say you wanted to solve a specific problem, you looked at the data understanding and you found that, oh guys, someone is writing. Who is that? On my screen, I'm not sure. Am I giving someone access to write? I don't know. Oh, now is it fine? Okay, thank you. Just bear with me, folks. I'm connecting using my hotspot. All right. So data understanding. Once you understand the data, maybe there is lack of data, or maybe there is some other data which can help you solve some other interesting business problem. Why don't you just iteratively work closely with your business team and help them redefine their problem or improvise upon their business problem? Once this is done, the third step is data preparation. Dealing with your outliers. Oh, Arun. Okay, friends, let me quickly check this. It's not at all usable. I didn't get you, Gaurav. Is my voice not clear, friends? Okay. Did it just start, or was it like this since long? Mm-hmm. Now how is it? Now is it okay? Can I continue? All right. So just bear with me, folks. Anyways, the recorded video would be given to you. Yeah, it's a connection issue. Then it. My bad. Okay, the third step is data preparation. Within this, You start dealing with your outliers. Whatever gap analysis you have done, you'll try to fix that. You'll try to identify the important features. You apply transformations. You create new features as part of feature engineering, so on and so forth. Quality of data should be improved as part of data preparation. Once this is done, you build your model, right? You build your model, you fine tune your hyperparameters, and then evaluate your model. When you evaluate your model, you test it against the test data and you determine the accuracy, check whether your model is overfitting or underfitting, etc. And in the business understanding, you would have defined the evaluation metrics on what defines the success of your project, right? Here, after you test the model on the test data, go back and check whether it's meeting your evaluation metrics or not. And then finally deploy the model in production the way you want to. Okay, most widely used. Next session when we are going to have on crisp DM, it's a complete 4-hour session. I'll ensure that internet issues do not arise. Sorry for that. Then the last model that we're going to discuss is called as SEMMA. This has series of 5 sequential steps for building machine learning models. And it was incorporated in SAS E minor, a very costly GUI-based tool from SAS, right? Okay, here are the 5 steps. First, sample. It's all about selecting a subset of most useful data from the large database. So you'll have a large database. You sample out a small data which is important for you. Okay, and this will help you build a model basically. This is very common sense driven, right? It's nothing extraordinary about that. But at this stage, you actually split the data into training and test, or training and validation. According to SEMMA, in sample, you split the data also. The next step is exploration. In this phase, you perform activities to understand the gaps in data. What data are missing? What do you need? What is the relationship between the data? What is the relationship? And the 2 key activities that you perform here is perform univariate as well as multivariate analysis. Univariate means you take single variable at a time and analyze it. Multivariate means you combine multiple variables and understand it. In univariate, you understand about the probability distribution, okay, of the data. Whereas in multivariate, you try to understand the relationship between the various variables. Here you resort to majority of data visualization techniques, data viz. Once exploration phase is done, you move to modify. Here is where you clean your data. Here is where you apply feature engineering to come up with derived features. Okay, you apply a business logic here and then try to come up with more variables. For example, if there are 2 people and if I have the debt and say this person has a debt of $10,000, this person has a debt of $100,000. You might be tempted to say that person B has more debt. No, you have to look at income. So you're applying a business logic. And then maybe this person has a salary of $10,000 per month, but maybe this guy has $1,000,000 per month, right? So this guy has less debt by dividing debt over income. You get to a new variable. That's the business logic. You apply it here. And the output of this modify phase is a clean data set with meaningful variables which using which you can proceed to the next step, which is model. So you build your model, you fine tune your model, you do all of those here. And the last step is assess. You're going to evaluate on whether your model is working well on the test data. Is it reliable and is it useful for business? If it is not useful for business and if it achieves even 99% accuracy, you throw it into a dustbin. Right? Meaningless, even if you can achieve 99% accuracy, and if it is meaningless for business, businesses won't pay you. Right? And just to recap, here are the three models. KDD, oldest, this started in 1996, but it took 3 years for them to publish that. And then you have SEMMA, last model. This I majorly use, but I should not be biased here, right? Just because I use does not mean everyone else in the industry is using that. I've seen a lot of organizations resort to SEMMA. A few of the organizations are still using KDD. But if you ask me, based on my experience, these two are heavily used. Right? KDD is not that great. I mean, this is just a gist, friends. In each step, there'll be again a lot of sub-steps, sub-modules. And you'll have a lot of documents and checklists that you have to satisfy in order to move to the next step. Right? It's not as simple as you just have this high-level understanding, right? So in the next webinar, we'll discuss about CRISP DM in further detail. Even before you guys drop off, we have annual Jumpstart scholarship program. As part of this, up to 90% scholarship is what people can expect. And if you enroll for any of these programs, then the main program, all these programs are for 16 hours. Our flagship program is for 120 hours, data science, 60 hours for AI. On all of these high-end programs, you get additional 50% discount, strictly for people who enroll for the scholarship program. We also have data science for internal auditors and accountants, AI-based conversational chatbot building, machine learning on cloud, etc. All right. We also have domain analytics. Healthcare analytics is for 40 hours. We're going to start it on 6th Jan for people from life sciences and healthcare background. Then we also have financial analytics. We are starting that also in the month of Jan, and marketing analytics in the month of Feb. This is for people who hail from those specific industries. We want to give you all those programs which are more relevant for your domain, for your industry. Having said this, here are the review links. I request sincerely you guys to please like us, share us, throw your reviews on social media forums. And yeah, I'll take your questions now. Okay, Swati, thank you for that. All right, friends. I understand that there was internet glitch and all that. I apologize for that. But I'm open to taking your questions at this point of time. People who do not have any questions, thank you so much. People who have questions, please ask. I'll be more than happy to answer. These recorded videos will be posted on our social media groups. So you might want to just be active on that.